In today's lesson, we are going to be looking at the area and perimeter of composite shapes. Right, so just as a quick overview, perimeter is the total distance around the outside of a shape. It's essentially the sum of all of its side, and it's measured in linear linear units. So this means like centimeters, inches, feet, meters, things like that. Area is the amount of space inside a shape, and its units are squared. Right, so the meters squared, inches squared, feet squared, centimeters squared. I should say inside a two-dimensional shape, because if we're talking about volume, that would be the amount of space inside a 3D shape. And if we need to, and for unit conversions, if we need to convert between units, we need to use proportional reasoning. So I'll go all the way back to unit 1, where we set up a pair of equivalent fractions. We cross-multiplied to find our missing value. So if you have to convert in units, use proportional reasoning. Now for composite shapes, what is a composite shape? And this is a composite shape that we have here, right? So this weird looking figure is what we consider a composite shape. And a composite shape is a shape made up of two or more basic shapes. Right, so if I look at this shape here, I can divide this up into some different shapes. Right? I can divide it up into a triangle here. I can make a long rectangle, a semicircle, and another triangle. If I wanted to, I could probably I could divide it up into, maybe it looks like a couple squares. Right? I could divide this triangle in half. But the idea is we can divide it up into basic shapes. Now, obviously, this would be the fewest shapes, but our basic shapes are our common ones, like our rectangles, our triangles, circles, semicircles, parallelograms, or trapezoids. And basically, what are the basic shapes? Well, if you don't know, you can basically look at the formula sheet that you'll be given. It's basically the shapes that we have specific formulas for. Right? So if we look at the formula sheet here, right, we can see a rectangle, a parallelogram, a triangle, a trapezoid, a circle. Those are the basic shapes that we're talking about. So a composite shape is made up of those basic shapes, two or more of them. It could also be shapes added together or shapes subtracted as well. Right? So it varies, or it depends on the situation. But those are examples of some of the basic shapes, and the composite shape is just a figure that is made up of them. So let's take a look and find the area of the following shape. Right, so we see a composite shape here. I want to break it up into a shape that I'm more familiar with, or the basic shapes, so that I can use my area formulas. Right, so I'm going to take this one, and there's different ways you could do it. Right, you could divide it across here, create a rectangle and a smaller rectangle. Maybe it looks like a square. We can figure that out. You could also divide it up this way, where you have two rectangles. You could also imagine that this little corner was filled in, find the area of the entire shape, and subtract this little portion here. So there's many different ways you can go about solving some of these questions, obviously depending on what type of shape, but there could be multiple ways of solving. So I'm just going to go with the first one we did. I'm going to say we cut across here and we come up with our two shapes. Right, so I have to find the area of this shape and the area of this shape and then add them together. So the area of the first one is relatively straightforward. We see that it's 11 by 11. Right, and the area of a rectangle, or any four-sided figure like a rectangle or square, is just length times width. So in this case, 11 times 11, we get 121 centimeters squared. That's the area of the first one. For the second one, it's still going to be length times width because it is a rectangle or maybe a square, but I need to figure out some other dimensions. I know that one is 6.5, so we'll call our length 6.5. I need to figure out this portion here. Now, we can see that the entire shape, or the entire length, is 18. And this little portion here is 11. So then the remainder, or the difference between 18 and 11, will have to be our side length down here. So 18 is from here to here, and 11 is from here to here, and this portion here, which we can see over here, this portion here is going to be 18 minus 11, which is 9. So that side length is 9. So that means in our formula, 6.5 times 9, we get 58.5 centimeters squared. And then our total area, or the area of this composite shape, is going to be the first area plus the second area, or 121 plus 58.5. And we get 179.5. And then centimeters squared. So that is our total area for this composite shape. The next one, this one is a little bit more straightforward in terms of what shapes you could divide it into. I'm going to divide it across here and make a triangle and a square, or a rectangle. Now you could imagine that it is a larger rectangle and subtract these two triangles off to the side, but then you have to make some assumptions about the triangle and then use Pythagorean theorem or sum of squares to calculate the side lengths, and it just gets a little bit messy. Right, so this is an easier one, just dividing it up into a triangle and a rectangle. Area 1, area 2. So area 1, I'm going to start with the rectangle. Again, straightforward, length times width. I get 21 times 16. 336 centimeters squared. The second area, so the area of a triangle, and again, if you're not sure what these areas or the formulas are, again, you can always go back to the formula sheet. We see a triangle. I'm going to focus on this bottom, or this top one, base times height divided by 2. Right, so what we see here, base times height divided by 2. If I go back to my diagram, right, I see the base is 21 because it shares the same base of the rectangle, right? Parallel sides are equal. So 21 times the height. So I need to figure out the height. Again, I do have enough information. I'm told that this portion is 16. The height of my triangle will be the remainder, or the other portion, which should add up to 32. So this portion here, or this height, is going to be 32 minus 16, which equals 16 centimeters. So that means the area is 21 times 16 divided by 2. Seems to be the same measurement. So 336 divided by 2 is 168 centimeters squared. Now that I have the areas of my two shapes, I'm going to add up the areas to get the total. Area 1 plus area 2 is equal to 336 plus 168. And I get 504 centimeters squared. The next one is asking to find the perimeter of the following shape. Right? So we see we have a rectangle with a semicircle on top. So I'm going to divide it up into those different shapes. Even though I'm not going to calculate the area, I'm just going to do that to at least start to label my sides. So remember, perimeter is the distance around an object. So I have 14 meters on the bottom, 6 meters on the side. Because it's a rectangle, that means it's 6 meters here. The only one I don't have is this semicircle. I don't have that distance. Now the nice thing is I do have a formula for the perimeter of a circle. So if I go back, I can see on the bottom here, perimeter of a circle, and we have C equals pi times D. So for a perimeter of a circle, it has its own name or a unique name for the perimeter, and that is what we call the circumference. So we have the circumference of a circle. There's two different versions for it depending on if we're given the radius or the diameter. But in this case, we're given the diameter. And the diameter is the entire distance across from one side of the circle to the other, going through the center. So this would be the diameter. So then C is equal to, is equal to pi times the diameter. Pi, if you don't know what pi is, it's delicious. I'm joking. Pi is 3.14. It is a irrational number. It does keep on going on forever, but we can use 3.14, or you can use the button on your calculator. Either is fine. You might get a slightly different answer, but it shouldn't be too far off. So C equals pi times diameter. So we take 3.14 times 14. And we get 43.96. But there's one thing we still have to do. That is for a this circumference is for a circle. We need to figure out a semicircle. So because it's a semicircle or half a circle, I need to divide my circumference. I have to divide by 2. And the reason I'm dividing by 2 is because it's a semicircle. So in this case, I get my circumference of the semicircle is 21.98 meters. We'll put that over here, 21.98. Now I can find the perimeter, which is just all the sides added up. So 6 plus 21.98 plus 6 plus 14. In the end, I get 6 plus 6 plus 14 plus 21.98. I get 47.98 meters is our perimeter. Right, so this one we had to do a small calculation beforehand to figure out the circumference or the circumference of a semicircle, which I could then add to all the other sides to find the perimeter of this composite shape. The last question, right, so more of a word problem. Crosley is looking to replace their turf field in the new year. They've recorded the following measurements. Determine the cost to replace the turf if they were quoted a price of $15 per square foot. Right, so a couple things we need to note. One, they're replacing the cost of the turf, or they're replacing the turf. So that is the entire area on the inside. So the turf is the fake grass. So if you're not sure what turf means, it's the fake grass. So it's the entire portion on the inside. So that means we are finding the area. Actually, we'll highlight this one. Place the turf field. So we're looking for the area. The other thing we're told is the cost per square foot. So we need to convert because our measurements, you see here, are in meters. So I need to convert. But luckily, I am given a conversion factor of 1 meter is equal to 3.28 feet. So we are going to have to do a little bit of unit conversion first before we can use our formulas. Now, one thing to keep in mind, right? Our conversion, or what we're told, is 1 meter is equal to 3.28 feet. This doesn't mean if I had 10 meters squared, could I just take the 10 meters squared and convert it based off of this to feet and get feet squared? No, we can't. Right? We can only convert between the two units that were given, meters and feet. If we found the area in meters squared, we'd have to use a different conversion factor. So keep that in mind. So in this case, we have to convert before we go through and figure out the area. Now, if you had a conversion for meters squared to something in feet squared, then you could do the area first in meters and then convert the final answer. but we don't have that right now. So we're going to convert using proportional reasoning. So 1 meter over 3.28 feet is going to equal 30 meters over an unknown amount of feet. We said, so it needs to be kind of paired up. So meters and meters, feet and feet. I'm going to cross multiply. And I get that basically x, or 1x, is equal to 3.28 times 30, 98.4 feet. And I could divide by the value in front of x. However, because it's 1, I don't need to do anything. So I do know now that this kind of distance across the track is 98.4 feet. I need to do the same thing for 100 meters for the other measurement. Oops. So 1 meter over 3.28 feet is equal to 100 meters over an x number of feet. Cross multiply. We get 1x, or just x, is equal to 328. Oops. So this 100 meters is actually 328 feet. Now that I've converted it to the correct units, let's go through and break it up into composite shapes. Right, so if I just quickly sketch it, because I have some stuff written there. Oops, maybe I'll try a little bit neater. Oops. So one end straight, the other end. So looking at this, I should be able to see a rectangle in the middle. Right, I have a rectangle in the middle, and then I have two semicircles on either end. Right, so that's what I need to break my shape up into. Right, one rectangle, and I have one semicircle and another semicircle. So because I have two semicircles and they share the same measurement, I technically have one circle. Right, so I have a rectangle and one circle. Now you don't need to go through and draw draw like a rough sketch and show me what you're breaking it up into. You could do that over here as well, right? And figure that out. But I just wanted to do that roughly just off to the side quickly just to organize my thinking. So the area first, we'll say the area of the rectangle, length times width. I have the length and the width. It is 328 times 98.4. 32,275.2 feet squared. The area for, I'm going to say a circle, because I have two semicircles. Again, if you don't know the formula off by heart for a circle, you can always go to your formula sheet and we see that it's A equals pi r squared. So A equals pi r squared. Pi is 3.14. R is the radius. So this is our diameter. So that's the diameter. We want the radius, which is half of that. So the radius is equal to the diameter divided by 2, or in this case, 98.4 divided by 2. And we get 49.2. So area of the circle then is 3.14 times 49.2 squared. And we get an area of 7,600.8 feet cubed. And because we need to find the total area is equal to the area of the rectangle plus the area of the circle. So 32,275.2 feet. I'll save those units for the end, plus the area of the circle, 7,600.8. We get 39,876 square feet. Now, we're not quite done, so we know how much turf is being used or needs to be replaced. We do have a price, so we need to figure out the cost. So we take that area, 39,876, multiply it by $15 because it's $15 per square foot. And we get that it's going to cost us $598,140. Therefore, 98, $140 to replace the turf. Right, so it's a lot of turf to replace, and it would cost us a large sum of money. But again, the main thing from this unit or from this lesson is looking at composite figures, right? The idea that they're made up of basic shapes and just understanding that we can break it up or break up the composite figure into those basic shapes to figure out the area or the perimeter, whatever the case may be. So again, if you don't need to remember, you won't need to memorize the formulas of the basic shapes. You'll be given the formula sheet for that, but just make sure you know how to use them.